Welcome back, BC Calculus students. We're going to go over some implicit, and then we're going to do second derivatives implicitly as one of our extra topics that we're covering. So this was actually question 102 from the summer work. So if you happen to get this one incorrect and want to look it over, you can. If you did this one fine and you want to skip through this part, you can do that as well. So looking at this problem, it's in terms of x and y. So if we're trying to find the first derivative, we'd have to do it implicitly because y is not by itself. And we have two options. We could FOIL this side, but if I did that, I'd be left with negative x squared y and an xy when I do these, and that would require two product rules, where if I look at this side as it is, I could just do this derivative using one product rule and then FOIL it afterwards. Okay, so we're going to take the derivative, both sides with respect to x. So the left-hand side, the y squared, we're going to get 2y times dy dx. And on the right side, we're going to do our product rule. So we're going to have our u and our v. So u dv plus v du. That is our product rule. So u, there, x minus y, dv, so dv would be 2x plus the derivative of y would be 1 dy dx. Plus, now we have v du. So this is going to require two FOILings rather than two product rules. So either way would have been fine. So now plus v du. So v is just x squared y. I'm just going to go down here. X squared plus y. And then du is derivative of x minus y is 1 minus dy dx. So now we're going to have to FOIL twice rather than doing the product rule twice before. So either way would have been fine. So now if I simplify this, we're going to go over here. So we get 2y dy dx equals, so now we're going to start to FOIL. So this first set of parentheses right here, we're going to FOIL this out. So we're going to get 2x squared, and we're going to get plus x dy dx, and then minus 2xy. I just like to keep everything in alphabetical order, it's just easier for me, minus y dy dx. And now we have to FOIL the other part, plus sign in between, plus x squared minus x squared dy dx, plus y minus y dy dx. All right, so hopefully this simplifies, which I think some of it will, or we can at least combine some like terms. So 2y dy dx on this side, and minus y dy dx, and minus y dy dx. These are all like terms because they all have a y dy dx. So if we add the other two over, we get 2y dy dx. We're going to add the other two over, so that will give us a total of 4y dy dx. Now, any other like terms? We have an x squared dy dx. I think that's good. So now bring over any terms with dy dx. So this term I'm going to subtract over, minus x dy dx. And then this term I'm going to add over. And then everything else stays on the other side. So we have our 2x squared plus x squared. So we can actually combine these two into one term to get 3x squared. And we've got our minus 2xy. And then we have our plus y. And now on the left-hand side, we factor out dy dx from all three of these terms. Here. Just focus on those. So we're going to take out the dy dx. We'll be left with 4y minus x plus x squared, and then it divides over to the other side. So I'm running out of room, so I'm just going to write this as dy dx equals, so this right-hand side stays the same, 3x squared minus 2xy plus y, and then we would divide by the factor we get on the left-hand side, which would be 4y minus x plus x squared. All right, so that was our number 1 and 2. That was a little long because there was a lot of algebra involved, but that was just a review of how to do implicit differentiation. And like I said, if you had FOILed this out first, that may have been easier for you. It may have been easier for us if we did it that way too. Okay, so let's look at second derivatives. So second derivatives can be a little tricky because you're doing this implicitly. So this original function, if we're trying to find d squared y dx squared, we have to find dy dx first. Right? Because the only way to find the second derivative is to take the derivative of the first derivative. So we're going to do that here. Our original function, we're going to take the derivative of both sides with respect to x. And this one's pretty easy because we don't have any of those product rules that we had in the last one. So the derivative of x to the fourth is 4x cubed. And then the derivative of plus y to the fourth would be plus 4y cubed dy dx. Because remember, you're treating y as a function of x. D dx means x is the independent variable, not y. Okay. So right here, when we took the d dx, x is the independent variable. And then the derivative of 16 on the other side is just 0. So now this one's pretty easy. We just need to get dy dx by itself. So if we subtract the 4x cubed and divide the 4y cubed, dy dx is minus 4x cubed over positive 4y cubed. And we can simplify this. It's always best to simplify your first derivative because we still have to take another derivative. So this would be this negative x cubed over y cubed. Okay, so that's our first derivative. So I'm going to erase what we have here and just keep our first derivative there. Okay. So that was just our implicit, but now we're going to take the second derivative. Okay. So our dy dx that we just had was negative x cubed over y cubed. All right. So now we need to find the second derivative. So we need to take the derivative of both sides again with respect to x. Since there's a y on this side, we have to do it implicitly. So again, we have to take the derivative of this with respect to x. So the left-hand side becomes our d squared y dx squared. That's just a notation for second derivative. And now on the right-hand side, we've got the quotient of two functions of x. So this would be a quotient rule. Remember, quotient rule is low d high minus high d low over the square of what's below. So our fraction. I'm going to do low, which is y cubed, d high, derivative of negative x cubed is negative 3x squared. Make sure you use parentheses or else it looks like subtraction rather than multiplication if you don't put the parentheses there. Minus high, so minus negative x cubed. So I'm just going to change that to a plus x cubed. So I don't have the two negatives there. D low, so our d low is going to be 3y squared. And then don't forget we have to have the times dy dx because this is implicit. We're treating y as a function of x. Parentheses on that as well. Over the square of what's below, and the square of what's below would be the square of y cubed, which when we simplify that will become y to the 6th. So now we have to be a little careful here. So we're going to simplify. So we've got d squared y dx squared equals. So on top we've got the negative 3x squared y cubed plus 3x cubed y squared dy dx all over y to the 6th. So now we could definitely reduce this if we wanted to. We've got a y cubed on top, a y squared on top, and a y to the 6th on the bottom. So we can reduce everything by y squared. That can cancel. This can become to the 1 power, and then this one becomes to the 4 power. Canceling. And now we have to look at the original question. The original question said to find dy or d squared y dx squared in terms of x and y. This is in terms of x, y, and dy dx. So this is a problem. We can't leave the dy dx in this answer. So what could we replace dy dx with? Well, remember back here, this is what dy dx equals, and it's a function in terms of x and y. So now we can substitute that. So our top fraction becomes negative 3x squared y to the 1 plus 3x cubed. And now we can do our substitution. replace dy dx with negative x cubed y cubed. And then the bottom, we have our y to the 4th. And if we wanted to simplify this so it's not a complex fraction, because we've got the y cubed on the bottom here, we could multiply the top and bottom by y cubed, just to get it a little more simplified. And if we multiply the top and bottom by y cubed, and I'm going to switch the first two terms in the top, or actually no, they're both going to be negative. So if we wanted to, we could factor out a negative 3, but let's not worry about that. Let's just multiply the top and bottom by y cubed. So that's going to give us negative 3x squared y to the 4th. Plus, now this y cubed on the bottom will cancel. I'm just going to show you what we're doing here. Y cubed. Distributing over, so the y cubes cancel, so that gives us minus. So we get minus 3. We're going to add the exponents x to the 6th. The y cubes cancel, and then everything all over y to the 4th. And remember, we can't cancel the y to the 4th because there's only one term on top of it. If we wanted to, we could do some factoring, but we're just going to leave it like that. All right, so for the last example is a little bit easier because they give you dy dx. So now for this one, again, they want you to find the second derivative in terms of x and y, but now we're being given the first derivative. So we don't have to do all that work to find dy dx because dy dx is given. So we just want to take the derivative of this with respect to x. But it has to be done implicitly because, again, this function is in terms of x and y. So the left-hand side, the dy dx, when you take the derivative of that, you just get your d squared y dx squared equals. Now, if you want to, you can distribute the 3, make it easier. The derivative of 3x is just 3. The derivative of 3y would be 3 dy dx. Okay, and this is the most important part, is making sure you put that dy dx there, because now we have to substitute. This is the trick with second derivatives implicitly, is that there's usually going to be this function dy dx that you have to substitute. And what do you substitute it with? Go back to what was given. What does dy dx equal? 3 times x plus y. So d squared y dx squared equals 3 plus 3. And then whenever you substitute, use parentheses. We're plugging in the x plus y. And if you want to now, you could distribute. 3 times 3 is 9, so you could distribute 9 and get 3 plus 9x plus 9y. So that one was a lot easier to find. All right, and that's one of the ones that we commonly see on the AP exam, second derivatives implicitly. So I'm going to post a worksheet. There's only, I think, 6 problems on there for you to practice. A few of them you have to find the first derivative and then the second derivative, and then the last 2 you only have to find the second derivative. Okay, so if you want to get that in by Monday afternoon, okay, so I can have a chance to look at it Tuesday, because then on Wednesday we'll be back together. That would be great. And again, remember, you can message me with any questions you have. I will be available throughout the next couple of days and things like that. All right, good luck, guys.